commons. In this video, we'll see how game theory can be used to model and explain this phenomenon. In the next video, I'll show some strategies for addressing the tragedy of the commons, also using game theory. The tragedy of the commons involves decisions by individuals that do not ultimately lead to the best outcome for all. To understand how this can occur from a game theory perspective, I want to return to the advertising example we saw in earlier video lectures. Here, two companies were deciding whether or not to advertise. In our analysis of this game, we saw that the dominant strategy for both players is to advertise, even though each company's net revenue is $2 million less than if they both chose not to advertise. That is, that Nash equilibrium, which is the outcome that game theory predicts, is not Pareto optimal, the outcome we would expect from a free market. This is the same kind of scenario we'll see in the tragedy of the commons. Let's go over a few definitions. We define a commons as a limited resource shared among many users in such a way that each user makes as much use of the resources they want. But once some of the resources used by one member, that portion is no longer available for use by another. Here's a few examples. As you saw in the TED Talk, a fishery is one of the classic examples of a commons, and many ocean fisheries have experienced a tragedy of the commons. Aquifers are another example of a commons. Although aquifers do refill, they often do so much more slowly than human beings withdraw water, making them a limited resource. The Ogallala Aquifer, which sits under a large section of the Great Plains, supplies irrigation water for almost a third of the irrigated farmland in the United States, and it supplies the majority of drinking water to people living in the region. The amount of water stored in the Ogallala Aquifer water holdings have been decreasing, and there is currently debate about how to best address this issue. This is another example of a commons. Finally, we can view the atmosphere as a commons, where the resource is the ability to store carbon dioxide emissions. Here, I've added two additional examples, one of which can be viewed as a commons and one of which is not. Highways are generally open to everyone to use. However, the space on the highways is limited. When too many people use the highway, there is congestion and everyone is less able to use the highway effectively. Thus, the roadway space can be thought of as a commons. Seating space in a passenger airplane is similarly limited. However, these seats are not freely available for use. Rather, individuals purchase tickets. Although airlines do sometimes sell more tickets than they have, the fine print on tickets normally include the rules by which passengers get bumped. Thus, seating on an airplane does not satisfy the definition of a commons. Now we can formally identify our key idea. The tragedy of the commons is the situation where rational exploitation of an unregulated commons leads to overuse of the resource, making everyone worse off. Note that this outcome is contrary to what the market paradigm suggests, and is the kind of outcome we saw in the advertising example. The term tragedy of the commons was inspired by the historical use of common grazing area in Britain. Here's a story that describes how the tragedy of the commons might come to be in such a situation. Once upon a time, there was a small village in a forest with a single large common pasture. It was called the commons, meaning that everyone could use it. The people of the village had cattle that they kept on the commons for milk and meat. By tradition, each household had only one animal that they released on the commons. Nobody got rich, but most of the time everyone had enough to eat, and the grass on the commons was green all summer long. One day, some of the villagers were talking, and someone suggested that they do away with the one household, one animal rule. "What's the point?" they asked. "There's grass enough for all, and I could certainly use a few more cattle." At first, the cattle population grew slowly. The benefits were easy to imagine. Having another cow in the pasture would bring more milk and cheese, and a cow or bull would provide more meat later. The villagers always had enough to eat, sometimes more than enough milk and meat. Life was good. But someone noticed that the grass on the commons was not as lush as it used to be. They worried, if we keep on adding cattle to the commons, the grass will get overgrazed, and then what? People heard the warning and considered it. But when each householder had a new calf, they considered the pluses and minuses this way. The plus. If I keep this calf and add it to my small herd of cattle on the commons, I'll have one whole extra animal for milk, meat, and leather. This is a substantial benefit to me and my household. The minus. The cost of adding this calf to the commons will be a decrease in the amount and goodness of the grass. All the cattle will have to forage harder, and all the cattle might not be as fat as a result. Each family decided to add their calf to the commons. Let's put this in a game theory framework. The players are the individual farmers. We can imagine the game being played in multiple rounds, where at each round a farmer is choosing between two strategies: to add a cow to the commons, or to maintain the number of cows they already have. Now we can use game theory to understand the best choice strategy for each farmer, that is, the Nash equilibrium for each round of this game. To further analyze the grazing example, we'll simplify the game by assuming we have only two players, and we are only concerned with the milk production of the cows. We'll suppose that the milk production of each cow depends on the number of cows in the pasture, using the formula 10 minus n over 2. For example, suppose each farmer has one cow in the commons. This means that there are a total of 2 cows on the commons. Then the production per cow is 10 minus 2 over 2, or 9 gallons. Since each farmer has one cow, each farmer gathers 9 gallons of milk. If instead each farmer puts 2 cows on the commons, there are a total of 4 cows. Then per cow, we have 10 minus 4 over 2, or 8 gallons. And per farmer, we have 2 minus 8, or 16 gallons of milk produced. Here, I've gone through this calculation for several different values of n. For each of these calculations, I've assumed that both farmers have the same number of cows on the commons. Note that the total milk produced per farmer is maximized when each farmer has 5 cows on the pasture. We can use game theory to understand if the farmers, acting rationally, will actually settle on this number. Let's first apply game theory in the scenario where each farmer currently has 1 cow in the pasture and is deciding whether or not to add another cow. From the table on the previous slide, we know that each farmer produces 9 gallons of milk if they each have 1 cow. Also, if each farmer adds a cow, so that they now each have 2 cows on the commons, we know that they each produce 16 gallons. Now let's fill in the 2 remaining cells in the payoff matrix. If A adds a cow and B doesn't, then there are a total of 3 cows on the commons. In this scenario, each cow produces 8.5 gallons. Since the farmers have different numbers of cows, their total production is different. A has 2 cows, so produces 17 gallons. Whereas B has 1 cow, and so produces 8.5 gallons. So now we can fill in the payoff matrix. The analysis is similar but reversed for the other unfilled cell. Now let's try to identify a dominant strategy for each farmer. Start by considering best choices for A. If B doesn't add a cow, A's best choice is to add a cow. If B does add a cow, A's best choice is again to add a cow. This shows that adding a cow is a dominant strategy for farmer A. consider B. Whether or not A adds a cow, B's best choice is always to add a cow. Again, B's dominant strategy is to add a cow. This shows that in this scenario, the rational choice for both farmers is to add a cow, and this does result in overall higher milk production. But this changes when we reach 5 cows per farmer. Let's first identify the dominant strategy for each farmer. Here, I've already computed the entries in the payoff matrix. Start by considering best choices for A. If B doesn't add a cow, A's best choice is to add a cow. If B does add a cow, A's best choice is again to add a cow. This shows that adding a cow is still a dominant strategy for farmer A. And we get the same result for B, that adding a cow is the dominant strategy. So the rational choice for both farmers is to add a cow, even though the milk production for the farmers decreases from 25 gallons down to 24 gallons as a result. Thus, the farmers have created a tragedy of the commons, decreasing the overall effectiveness of the commons despite making the rational best choice for themselves at each step along the way.